Well, hello there, everyone. This is KP, the Math G, and I've been kind of a little bit busy in the garden now lately, actually fixing up a garden, and hadn't planted. Well, I've got two small gardens. I got one of them planted, and I'm working on the other one, and got a variety of food and some vegetables that we're going to grow out there. It's going to hope it comes out really nice. Anyway, we're at the 2009 free response question number 4, and I wanted to show this one to you because you get a variety of types of questions along this line, and you got to really think about what they're asking for here. So this one here, on this one, you got y is equal to 2x. That's that supposedly straight line there. It's not drawn the scale, as you can tell. You just got to imagine that that's a straight line. And then you got y is equal to x squared in the green, and we can see that that is a curve, a piece of a parabola. It's bounded by this, the region is bounded by these two curves. Alright, so we want to find the area of region R. So well, we can do that one of two ways. Okay. Obviously, since you're in for time, you want to do it the fastest way that you possibly can. And of course, what you would like to do is, it is going to be, now we're not revolving it, so it's not pi r squared, but we are taking an interval here, like so. And I know you can't, I know I'm getting better stuff, but sometimes, better markers. I have to separate the good ones from the bad ones. Alright, that one did a little better. And of course we got a little isosubinterval right in here. And we're really looking at the area here. We're not looking at this underneath here, so we're just mainly looking at this portion in here. Alright, so what we got to do is, we got to, with this height here, by the way, is y. Okay, I don't want to write too much on this, but this height is y. We'll call it y1. And then this height here, we'll call it y sub 2. Alright, and that's what we want to do. We want to take this entire height here, this entire height, minus this height here. Okay, you see what I'm talking about? The entire height is y1. This part that we're not considering is y2. So we're going to take that, we're going to subtract it. So let's see, we got y1, and of course we've got to figure out where we're integrating from. 0 to, this is 0, 0. We're going, our isosubinterval is running this way, perpendicular to the x-axis. It's going to run anywhere. I could put my interval anywhere between 0 and 2. You're only looking at those x values, so you got to get that part right too, setting up the interval. Y1 minus y2, and of course the thickness is delta x, but we put dx there. Alright, y1, now the height here goes to the blue line, that happens to be 2x, so 0 to 2x, alright, minus, and we're taking this part off now. It's always the higher one, the one above, minus the one below, if you don't learn anything else about this. Alright, this y2, we might make this one y sub 2. This would be, where is it? This would be y sub 1 right here. Alright, so y sub 1 minus y sub 2 x squared dx. And I don't know if you have to do this by hand or whether you can do it by a calculator. If you have to do it by hand, we know we're going from 0 to 2. And remember, this is 2x, where this is a 1. We've got to raise it up 1 and divide by 2. So this is just x squared. Alright, and then x squared, remember this is, we're just going to add 1 to that. That's x cubed over 3. So 1/3 x cubed, or just x cubed over 3. Alright, and we're going from 2 to 0. Oh, that's actually from 0 to 2. 0 will just make 0, so we're not worried about plugging 0 in here. So what we have here is 2 squared minus 2 cubed. 2 cubed over 3. What we have is 4. 4 minus 8. 2 cubed is 8 over 3. And then, of course, I can multiply, get a common denominator of 3. 3 times 4 is 12. So 12 over 3 minus 8 over 3 is 4 over 3. This would be in square units because you're looking for the area. So 4/3 square units, okay? Alright, that's the way that one would work, so that one's equal to 4/3. Alright, that's that one. Okay. Alright, now the second one, I hope my battery doesn't run out. I went outside after I got the camera set up. I went outside for about an hour or so, and so anyway. Alright. Anyway, and my battery went down some, so I'm hoping I have enough battery life to run this video. If not, I'll do it again. Alright, the second one is the region R is the base of a solid. For this solid, at each x, the cross section perpendicular to the x-axis has an area A at x. So B part A at x. I think that's what they're saying, this area. Well, they have it in a capital A, so alright, I'll make it capital. Alright, now they're making that sine pi over 2x. Sine pi over 2x. Okay, like that. Alright. Find the volume of the solid. Now, volume, remember, is the area times the width. We got length times width, whatever, the area times the height or whatever, times the thickness. We might say times the thickness in this case. Well, we already know what the area is. We're still going as perpendicular to the x-axis, so we're still going from 0 to 2. Alright, that's easy enough. Alright, the area we already know is sine pi over 2x, and the thickness is times delta x. Alright, so dx. There's your volume right there. That's it. Don't make anything too hard out of that. That is your volume. You're not spinning it around. You're just looking for the volume of this. And actually, that's what that is. So when you tack on that delta x, there's your thickness right there. Okay. Right there it is. You gotta remember, this is a 3-dimensional, or maybe height or thickness, whatever you want to call that. But anyway, that's what we're talking about here. And then when we integrate this, again, we'll let u. So let u is equal to pi over 2x. Du is equal to pi over 2 dx. Now remember, we want to get rid of that. Just get dx by itself. So 2 over pi times 2 over pi du is equal to dx. So what we'll do here is 2 over pi du. Alright, 2 over pi du. And again, if you know the antiderivative of sine, which is actually negative cosine, you can just simply put this in front. So 2 over pi times, well, let's make it negative because it is a negative cosine. So cosine pi over 2 x, and remember we are going from 0 to 2. Alright, so this is negative 2 over pi, right, times cosine of, if I plug 2 in here, this is going to be 2 pi over 2, which is just pi. I'm just plugging that 2 in. Remember, this is a numerator here. And then minus cosine of 0, 2 pi over 2 times 0, which is just cosine of 0. I'm going a little bit faster because my battery is low. But I hope you can catch what I'm saying here. 0 here, pi over 2 times 0 is cosine of 0. Alright, so cosine of pi, remember cosine does this. Alright, and then cosine of pi is negative 1. So negative 1 minus, and in this case, cosine of 0 is 1. So negative 1 minus 1, and remember we're multiplying that by, let's put it on this end down here, 2 over pi. I just got to put it on this end because I'm running out of room. 1 minus 1 is 2, negative 2. Alright, so negative 2, actually that's a negative 2 over pi. Alright, so this is actually negative 2, my goodness. This is equal to negative 2 times negative 2 over pi, which is equal to 4 over pi. Alright, and that's it. And that's going to be in cubic units because we're looking for the volume there. Okay. So that answer is 4 over pi. And then finally, let's look at the last one. Just remember, you just got to remember, if you can just remember that this u is pi over 2x, du is pi over 2 dx, and then when you can just say 2 over pi du is equal to dx, if you just flip this over and then get the antiderivative of sine, which is negative cosine, just put the negative on this right here. Plug in the two numbers right here, and then you will just, use the fundamental theorem of the calculus to figure out what this final answer is. So 4 over pi is B part. Alright. Alright, C part is talking about a square. Alright, but this time, tell you what, I don't know if I'm going to have time to do C part. I may do it at another time. Let me see how much battery life I have. Excuse me just for a minute. Let me look at my battery behind here. It is low. Okay, how low I don't know, but low enough. Alright, so let's see. The last one is, well, I say it's going to take a little more time to do this one, okay? But I may be able to squeeze it in. So we're going to try C right here. Alright, we'll try it. It is perpendicular to the y-axis, so we're just going to do that right there. And we're looking at a square. Okay, and so it's actually this, the furthest one to the right, minus this part right here. So this is x, this whole length right here is from here to here is x2. So actually what it is this, what we're looking for is this right here. That's what we're looking for. It actually should be a square, okay? When you draw that out, okay, it should be in the form of a square. So we are going to square it, whatever we do. Alright, it's this entire length here, x2, which in this case, well, we got to solve for x, don't we? Let's get rid of the subs, okay. So y is equal to 2x. So I'm going to divide by 2 right here. So x is equal to y over 2. You always do that when you have something perpendicular to the y-axis. You got to figure out what your x is. Okay, and that's what x is. All right. That one would be x sub 1, because this is the blue line here. Y is equal to 2x is the blue line. Alright, so that's x of 1. Here I'm solving here for x. That just means I take the square root of x squared, which means I take the square root of y. And that's just going to be x is equal to, we could say plus or minus, but in this case we are going to take it positive because we're looking at area here. Alright, so this is going to be the square root of y. Alright, so x is y to the 1/2. Alright, so this would be x of 2. And so x of 2 is this length here. Now remember, we're not revolving it. It would, if we did revolve it, we would have to do x of 2 squared minus x of 1 squared, but we're not revolving it. We're just finding the volume, just like we did in part B. Okay, that's what we did here. So we're just finding the volume. Again, delta x is that thickness. Okay, so we're just saying then x2, this entire length here is y to the 1/2, y to the 1/2 minus x of 1, which is y over 2, or 1/2 y, and that's delta y this time. And by the way, we're not going from 0 to 2 anymore, because our IFSUB interval that we chose could go anywhere from 0 to 4. We're looking at the y values at this point. So in this case, from 0 to 4. Do not miss that part. I overlooked it when I first started doing all this. I started overlooking that, and no, you don't overlook that. So if you're perpendicular to the y-axis, you got to use the y values. If you're perpendicular to the x-axis, you got to use the x values. Okay, so that's it there. And I'm going to go ahead and just give out the answer to this because my battery life is so low, so please forgive me if I didn't go ahead and integrate this. I could, we could expand this. We would have to expand this anyway, because this is a binomial squared, okay? And so when we do that, I'm not going to go through the expansion. I'm just going to go ahead and write out the final answer. Oh, it says do not evaluate. Okay, we do not evaluate that. So this is actually it right here. Okay. That's what we're talking about here. If something is squared now you got to be real careful about this, because you're not doing this whole length minus the square of this whole length minus the square of this part that's revolving around the y-axis. That's not what we're doing. We're just finding volume here. So the square